So, good evening, everyone. This is Ashok Kumar, PMO scholar from IIT Jodhpur, and today we have the live session class 4 for week 4 of that sensor and external V class. In this class, we will look into that questions and answers and some concepts and some doubt you have to post it on us to question form of the SWAM portals. Abhimanyu, hello, Abhinu. Okay, so we will go through that how to that MEMS sensor will be fabricated. What is the pressure sensors? What is cell-based diagnosis? What is antibody diagnosis devices? How to clean room will be work on that technology. Automobiles, we have to learn about that. Arduino, how do we get the IoT system enable our sensor to integrate with the Arduino? That's should we have to go through these lectures. If you have any doubt regarding previous week, that week 1, week 2, week 3, you can ask to unmute yourself and ask us. So, which of the following is true for the positive assist? Means we have to use the to make the any devices like that. This is my silicon wafer, and then I have deposit SiSi2. Then to sensing anything, we have deposit some materials here. This is sensing layer. This is oxide SiO2, and this is silicon. Okay. So to make the device, we have to deposit some photoresist, and then we have to expose the, in the case of the UV exposure, light will be exposed here, and whatever the shadow mask there is a, in between there is a shadow mask, some pattern will be there, so it will be deposit on that pattern. Okay, so we have the two types of the photoresist, one is positive and another negative. So in these questions, the we have uh, it is for you. So which of the following is true for the positive photoresist? So you have to respond. If you have any doubt in that things, we can discuss that also. So the first option is the exposed region of the photoresist during the exposure step will dissolve in the photoresist developer. The exposed region of the photoresist during the exposure step will not dissolve in the photoresist. To the unexposed region of the photoresist during the exposure will be dissolved in the photoresist. Okay. So what is the first doubt is the exposed region of the photoresist during the exposure. Means this is the shadow mask. We have the pattern on that shadow mask. This is the mask made of the glass. Like that, this electrode will be, we have to transfer to the our pattern, and UV light will be. This is the only the simple glass. So what is the exposed region? This is the exposed region. This pattern will be exposed on that day. During the extra step will be dissolved in the photoresist developer. Means whatever that things will be dissolved, not it will be not true. The exposed region of the photoresist during the exposed step will not dissolve. It is also not true. The unexposed region means whatever that unexposed region, it will be can to etch. We can remove through acetone, ethanol, methane. What is the type of the photoresist, and we can unwanted photoresist can be removed. Then soft break, during we have to deposition, we have to perform the soft break, hard break uh, to transfer the pattern. So what will be the meaning of the soft break? So soft break is harden the photoresist after the spin coat. What will we do the soft break? uh, Harden the photoresist before spin coating, soften the photoresist after the spin coating, none of that. So we have the silicon wafer, we have the spin coater. Last 2 or 3 class I have shown the photo of the spin coater video and everything. So when we have to drop, we have the photoresist, it will be transferred to the whole silicon wafers. And after that, what we have to do, we have to do the this wafer to soft bake on the hot plate around 50 degrees Celsius and between that 50 to 100 degrees Celsius. Okay. So what will you do? It harden the photoresist after the photoresist. It is harden the photoresist before, because we have to not do the soft work before the it is not true. Okay. It soften the photoresist after the spin coating. So it will harden the photoresist after the photoresist will hard some moisture that we have to, because this is in the liquid form, so we have to hard to that photoresist. So to transfer the patterns or to make the any devices, any sensors, what we have to do, we have to take the substrate first. This is called a substrate. Okay. Then what we have to do? Substrate can be made of the glass, mica, silica, sapphire. What is your requirement? You can choose the any substrate for your requirement and application of the sensors. So then we either so example, we have to the silicon, then we have to deposit again that SiO2 oxide layer, insulator layer, then we have to deposit some material layer, and then we have to pattern that. So photolithography is the sequence of activity needed for transfer of the pre-designed pattern to the surface of the semiconductor. Means we have the some design, this is the shadow mask, like that we like structure is like that, we have to transfer this structure to our wafer. Like that this structure we have to transfer on wafer. This will be happen through the photolithography. The pattern can be registered on the mask or supplied directly from a computer to scanning radiation source. ठीक है ना? So either it will be on the some mask, glass mask, or we have to save the design in the computer, some software will be there, and through that computer we can scan on a radiation source. So photoresist is a positive sensitive resistant coating used to register an image on the desired surface. So to we have to transfer that image on our devices. So photoresist will be contain that image of that device. So this is the history of the development of the photoresist. Okay. So during 1917, scale of means we can transfer the 1 kilobyte skin field, minimum line with 10 micrometer, and rubber based negative photoresist will become. Then again a rubber weight, that minimum line weight will be changed. Line weight means distance between the this line and these lines. This is 2 micrometer. So till 2008, there is 0.07 micrometer. We can transfer the image of the size of the 0.07 micrometer through the EUV 30 nanometer resist. This is the type of the name of the resist that have the wavelength, that exposure wavelength of the 30 nanometers. That. So I have already explained that type of the positive photoresist. We have the two photoresist. This is the silicon SiS2 and this is the photoresist layer. And this is the mask and this is the below that is the pattern we have to transfer on that SiS2. So what will happen when we, in the case of the positive photoresist, exposure UV light make it more soluble in the developer. Exposed resist is washed away by the developer so that unexposed substrate remain, result in the exact copy of the original design. So whatever that undesired photoresist is here, it will be removed through that, and it will be only that whatever the expected of the design will be there for us. Okay. In case of that negative photoresist, whatever the That unexposed area will be remain, but exposed area will be gone. Okay, so it is vice versa in case of the positive and negative photos. So what do you mean by the soft baking? Put on a hot plate or its oven. Like that you have to see in your home we have the oven to heat or to hot the some food, or in the laboratory, that chemistry lab, or you have to see that there is a furnace like that way. So we have the hot plate that we have to put that substrate to 65 to 150 for 1 to 5 minutes for soft baking. So what will be the role of the soft baking? It will remove the volatile solvent from the coating. Like the volatile compound will be acetone, ethanol, IPA, isopropyl alcohol, toluene. These are all the volatile organic compounds. So the photoresist we have to transfer that coating. We use these things, and it have some traces or some particle will be remain on that substrate, and we do not want them. So we do the soft baking. Make photoresist imageable. It convert the property so he can be the shadow mask image can be transferred on that devices. Harden to amorphous solids. Be careful not to overtake and destroy the sanitizer. Okay, what is the hard baking? Final step in the photolithography process. Means when we have to done everything, that transfer the pattern image, and we have to remove the unwanted photoresist, then we have to do the hard baking. After that, exposure of the our image device. Not always necessary, depend on the resist. Hard baking is not necessary. What type of the photoresist we have to use, it depend on that. It will be harden the photo to sorry, and improve the addition of the photoresist to the vapor surface. So this is the whole process, that flow diagram, how to positive photoresist process. So you can see that this is UV light, this is the mask. So this black dot we have to transfer on that our devices, and this blue will be an exposed area, means it will be not transfer. Then we have that this green color is the positive photoresist, and this is the substrate. When we expose the light, what will happen? It soft these things, unexposed area, and then we have to remove this and expose it. Then we have to do the depositions. Means whatever the materials you want to deposit, we can deposit on that material, either aluminum, chrome, gold, silver, copper, nickel. What type of the electrical contact, material contact you want to take, you deposit that material as per your desired sensors. Okay, so finished product, this is the finished. Then we have to do iron milling, means we have to remove that positive, only this material will remain and these things will be happen. In case of the negative resist processing, you can see that this is a mask and this is a. So what is the exposed area? It will be removed. Only unexposed area will be remain here, and exposed area. Then we have to deposit some that metal deposition and iron milling. We have to the. Any questions? Any doubt in this? So next we have to do. So basic photoresist process step, you can see that we have the vapor. This is the vapor. Then we have the addition. Then this is the cool plate. Then resist application. This we have to deposit the resist. Then we have to soft bake that resist. Then we have to again see that this is the step in process. Then this is the post exposure. We have to be a cool plate develop. This is develop. And after that post device, this type of the devices we have to fabricate transfer on that our silicon paper. So To remove that photoresist, unwanted photoresist on our devices during the fabrication of the sensors, we have to remove that photoresist. To remove the photoresist, the technique will call the etching. The removal of the photoresist is called the etching. After a thin film is deposited, it is usually has to remove unwanted material and leave only the desired pattern on the paper. Whatever the pattern we have to require, whatever the photoresist or contact we have to require, we have remain only that paper, and unwanted things we have to remove through the etching. The process is done by many times, means every step you have to do etch. If you or layer by layer you want to deposit, then every time you have to deposit the photoresist and everything. In addition to the deposit film, sometimes we also need to etch the silicon vapor to create trenches. Means this is a silicon vapor and we want to etch these silicon vapors to create some contact or the, so we use the HF here, some concentration HF, and we remove the SI here to make some trenches. The masking layer may be the photoresist Si2 or silicon nitride. So the etch is usually done until another layer of the different material is reached. So this is the general process used in the integrated circuit fabrication to define the pattern films. So we have the substrate here. This is a deposit film, some material will be there. Then we have the task of the photoresist. This is the mask of that we have to that resist removal. This is the development and soft baking. Then we have to do etching. Means this is the this photoresist will be removed here. And then what will happen? This resist will be removed. This resist. This will be happen in case of the positive photoresist. If this will be in the negative photoresist, then this will be removed and this will be remain here. So type of etching we are using during the fabrications. We consider two processes. One is the wet etching, another is the dry etching. So wet process is well established, simple and inexpensive. Means wet etching means we use the some chemicals. Dry means some plasma like structure, some machine structure which will be using the gases and everything to remove that photoresist. But in case of the wet etching, we use the some metal. Like if you want to remove the silicon, we use the KO solution to remove the silicon. Okay, like that we use the SU8 positive photoresist. It's the type of the positive photoresist. Then what? How to remove this SU8? We have the developer of the SU8. Then we have to make the essence of the SU8, and then we have to do the acetone, use and dry with the gray water and nitrogen blue, and we have to done this complete thing. Any questions? Any doubt? So what will happen in case of the wet etching? In wet process, by immersing the vapor in the this chemical, exposed area could be etched and wash away. For Si2, we use the HF. I already explained last slide. Wet etches work through chemical process to produce water soluble byproduct. Means like that we have to remove this Si2. We use the SF. Then this will be formed H2SiF6 plus 2H2. Means water will be the byproduct of that molecules. So this is the simple idea of the bead etching. Like that, etchant will be the KOH, HF, BF6, BCl3. So we use the HF to remove the silicon layer. So Si2SF, H2CX. So masking layer, this is a liquid etchant will become and this window will be open in that case. Next is the dry etching. So dry etching is the plasma etching. Plasma etching has for the most part there are two reasons. Very reactive ion species are created in the plasma that give rise to very active etching. Plasma etching can be very anisotropic because the electric field drives the ions. So what will happen? We have the there is a plasma system, and we have put our substrate here. This is the plasma, and this ion species will be striking through the plasma on that surface, and photoresist will be removed in that case. Okay. Sorry. So this is the schematic diagram of the RF powered plasma etch system. So you can see that we have to ground it. We have to use the gas argon CF4 oxygen. There is a gas our product of the RF system. We have to supply the RF supply, and we have the electrode and plasma chambers, and we have the electrode. So we have to, through the shadow mask, we have to put the electrode, and then we have to, in case of that plasma etching, dye etching will be done in the plasma chambers. So anyone see like that? Anyone have to perform the etching, or they are familiar with the photoresist in their lab? Have you completed assignment 3 and 2 and second quiz? Anyone? Have you submitted that assignment 3? Yes. Hello? Banala? Hello? Hello? I'm audible? So what is the plasma? So plasma, like that, this is the gas ions species molecules, so state of matter which consists of free electron and cations. It will be correct at the anion and cations, and this anion and cation will be react with that surface of that positive photoresist. This is the photoresist layer, positive or negative layer will be there. So it will be react with that, and through the bombardment of the ion species, this photoresist should be removed from that unexposed area of that UV light. Plasma looks similar to the gases. Plasma is also coordinated ionized gases. So dry etching, for etching photoresist we use that oxygen for dry etching. For other material we use species containing halides such as Cl2, CF4 and HBr. Sometimes H2O2 and argon may be added. The high energy electron causes a variety of the reactions. So what plasma, what will be contained in the plasma? Free electron, ionized molecule, neutron molecule, ionized fragment, and free radicals. Means there will be electron to react with that positive photoresist. Ionized, that some energy will be in the molecules. Some neutron molecules, some ionized fragmentations means division of that molecules for that fragmentation. Free radicals means unwanted, maybe that unwanted energy will be present in that plasma. So, uh, physical etching inside the plasma. Etching species are ions like that CF3 plus or argon which remove material by the ion bombardment. So this is the film, this is the mask, and this ion will be bombardment is the here. And through the ion bombardment we can remove the positive and our pattern will be transferred on that papers. So next is the health devices, cell based devices like that. Uh, if you are feel not well and suffering from some you have the suffering from some disease like that, you have that fever, and doctor said that you have to take injection for 2 or 3 days, and what will happen that drugs will be insert your body through that needle. Okay, syringe and needle. So what will happen in that case if that Nursing staff is not good. Suppose that he will be not trained and his hand will be in no regular practice. You feel the pain when he will be injected the drugs in your body through that syringe or nozzle. That have you experienced like that? Feel that it is too much, and some people are means have a phobia to take the injection. They are very so much afraid that they will not to face that they do not want to inject. They can take the medicine orally, oral medicine, and that's so. What technology will become that we have and what is the another case with the development of that technology? Medicine people want to deliver the drugs in the human body in the control menu and in the interval of time. Suppose that for that I want to injected 10 ml of the drugs throughout the 24 hours. So in nowadays what will happen? Means after 3 to 4 hours nurse will become, he will be injected through that drip or some syringe like that 2 ml 3 ml in our body particular time, and we have to face the pain in that case also. But now we have the sensors like that microfluidic sensors. What will be the microfluidic sensors? This is the structure of the sensors. This will be the inlet. It will be like that structure. It will be some channel or like that. This is just an example, not a proper, and this will be outlet woman. So when we have injected, it will be move here and remove here and there. It will travel to some distance and it will be injected in the body. So we have to design the sensors which can control the flow of the drugs in our body. So we make the sensors like that pressure sensor which controls the flow of that, like the drugs will come through the pressures, and we can measure that pressure, that if we want to inlet or deliver the drugs of the 2 microliter in our human body, so we can measure when we have to broadcast our 2 microliter on our sensor, what is the change in the property of the sensors due to the exposure of the 2 microliter of the drugs. Okay, so what will be happen in that case, like that we got the some electrical signal, like that we have the silicon devices, and if check the semiconductor property of the silicons, we can measure the IV of that silicon wafer, we can measure the resistance of the silicon wafer. So what is the resistance before to deliver of the drugs and whatever the resistance after the delivery of the drugs, the change in resistance we can calculate. Suppose that we have to insert the 2 microliter drugs to the human body, and suppose my device's baseline resistance is 10 kilo ohm, and it's depend upon the type of the material also, that how much the material will be p type or n type semiconductor materials, and whatever the stimulus physical phenomena that we have used, it will be react with the end of p type material and it will be behave as n type material or p type material. Our current of the device will be increased or decreased according to that. So we measure the change in the resistance and then we have to calculate. Suppose that we have to take the average or whatever 3 to 4 cycle, that my resistance change will be 5 kilo ohm. So we can insert that 5 kilo ohm in the Arduino or system, that if my devices have the baseline current of change in the current will be 5 kilo ohm, then it has the drug delivery of the 2 microliter in our body. So when that it is like the switch and circuit system like that. So in the market we have the smartwatch which have the GM healthcare vision devices. We have these type of the devices, blood and everything in our smartphone. Even people are checking the diabetes in the home and only on the home. Previously they have to visit to doctor and some syringe will be stuck on that here on the any finger, and our blood will be taken on the glass slide. This is a slide, and after they check that in the laboratory the diabetes value of the sugar value of the human body is how much. But nowadays what will happen, a small device like that is come, there is some strip, and we take the blood on that strip, and now digitally it will be shown on that meter that this is the your value of the sugar in your blood. In the last 2 years, from 2020 to 22, that whole the world will be face the problem the COVID. And what will happen? We have to monitor our SpO2 of the body, human body, because if the oxygen level will be go down, it will be critical for that human being. So we have to given one devices like that devices, we have to put in our finger, and it will be display that sp2 value of the human body. Like that our sp2 value will be changed from initially it is required above the 93% as the medical counseling, but if it will be below means it require the oxygen supply. We have to make the arrangement how to, because it is possible through that sensors only, who will monitor our oxygen level of the human body. So what will be happen, how to we monitor the oxygen body? He will check the flow of the blood in the human. If the oxygen flow will be proper, then flow of the blood will be proper in the human body. So sensor will check that how much the flow of the blood of the human body will be there. Okay, so it will give the 96%, 97%. If the blood flow will be not proper, it velocity will be decreased or flow will be decreased. So sensor will recognize that flow will be decreased. Okay, so he will be give the signal that 91% will be the oxygen flow in the human body. So due to the possibility of the sensors, now the everything will be on the mobile or on the hand of the human body. Portable things will become in the market. So our job will be to design the sensors which dimension will be small, and it can be integrated with the system through the IoT, AI, and machine learning. Okay, so these all the devices and all the things will be on the smart sensors. Like that, those are the who are very particularly about caring about their fitness, and the people are using that Apple Watch and iPhone. And now in the Apple Watch, you can check that heartbeat of the human being. You can check that how much the step you have to walk, how much the oxygen flow, how much the sugar, everything will be on the watch, this watch, smart watch. How it is possible? Because we put the sensor here on the body, and on that skin, like that when we have to move that step, it will be that displacement sensor will be here. How much the distance we have to cover. So that step that you have to take a 700 step, you have to travel the walk of 2 kilometers. So it will be average value given by that watch. So these type of this healthcare equipment will be available in the market. So what will happen? This is some example of the cell-based sensors. So first we have to take some pressure sensor. How to we fabricate pressure sensor? So I need one blank slide. Then we have to move again. I have to put 1 minute. Meanwhile, if you have any question, you can ask to me. So what will happen? Uh, like that, we want to make the pressure sensors. Okay, for cell-based sensor design. So previously you can see that step, like that I have taken the silicon substrate here. This is the silicon. Then I have grow the oxide layer here, SiSiO2 here. Okay. Next step, what will be I do? I want to sense the pressures. So I want to choose the materials which sense the pressure. So we So what will happen? We have to choose the piezoelectric materials, because piezoelectric material will be change the properties with the pressors. We pay the orientation of that material will be changed with the pressors. You can see, if you read that material science in your MTech or BTech or engineering service examinations, or physics of the 12th class, what is the property of the piezoelectric materials. So we have to deposit after that SiO2. This is SiO2, and this is the piezoelectric materials. We have the piezoelectric material. Okay, we have to deposit the piezoelectric material here also on the bottom gate. Okay, so then we have to transfer the electrode of the materials. So we use the shadow mask. uh, if it is not properly visible, let me know. Here we have to do the UV exposure. Some shadow mask, some design will be there. This will be transferred to the UV exposure. Then we have to do the etch and everything, short baking, hard baking, that step, whatever the required, we have to explain the previously class, or that instructor in the YouTube, you can go through that. So what will happen? How the pressures will be technology based? Have you like that heard the name of the diaphragm? So what will be happen? How the sound system will be work? Loudspeaker will be work. There will be some diaphragm will be there. When the sound pressure will be there, it change the property of the diaphragm. Okay. So we have to make the diagram here. So what will be happen? After that, everything will be happen. This is SiO2 and a positive electrode. These are the electrode will be here, aluminum cold, and we have to some make the diagram like that structure. Edge through that bottom, or this diagram will be fabricated on the below. Okay. So this type of the sensor we have to fabricate it, and when pressure will be apply on here, we have to take the bottom electrode, it will be move. These two are the move according to the pressures. Okay, and then we have to check that how will be position will be changed. So we can change the pressure of that sensors. Okay, so anything doubt? Any doubt? So like that cell-based sensor, you can see that example, cells-based sensors. These are the cells, drugs, biomolecules, DNA. We want to sense that. Okay, like that a cancer patient, how can we check that he have the cancers and what of the step? So what will happen? We take the some tissue from the human body, that cancer cell tissue, and we can transfer that tissue to our sensors, and he will be react with that material and will give that what is the what type of the sensor. But suppose that we have the blood cancers, so we can take the blood sample and we can transfer on the sensor like that. So they will be react, these are the some materials, same images and that optical images of some materials. So we have see that this gold is the electrode, this quartz crystal is the substrate, and this red dot will be cells in the culture medium, and we have to connect these two bottom to the oscillator and impedance amplifier PC. So this is the completely set up through the Arduino system. So we oscillator will be check that change in the voltage, current or impedance of that materials, and then we have to add impedance analyzer will be analyzed, and through the PC we can see that how much the result will be, we have to release. Okay, so you can check that these are the I have to. Okay, so this type of the cell based sensor will be fabricated. So this is just one example. So what will happen in the cell-based sensors? Utilize the principle of the cell-based assay by employing living cell for detection of the different analytes from the environment, food, clinical or other sources. Means we have the cell-based array on our devices. These devices have a lot of the array. This is the array we have to say. This is the array. And we can drop here, drop here, drop here, drop here, drop here of the cells here. Okay. By employing living cells means they are alive. Their sense will be not sensed by our the materials of different analytes like the environment, food have the some microenzymes, microbiology, some antibacteria will be there, bacteria will be there in the food. Clinical means blood sample, tissues, and other sources of the live cells we can detect. So we have the bacteria, yeast, invertebrate cells to create the CPP device, cell based biosensor devices. Living cells are directly integrated into the biosensor platform. 1 minute, please. So usually used in the biomedical fields. You can check that now the you can previously that doctor will be operate through that person some operation, but in the market now robotics will become robotic surgery will be new field of that medical will become the robotic surgery. Okay. Previously, to test some human body, some samples, we have to face some pain to take the samples and everything. But now, in the advancement of the technology, advancement in the devices, size of the devices will be reduces. So, improvement in the biomedical field will be scope of the biomedical field will be more in the futures, because people are making the devices of the biomedical in the medical field because market value is very high. Okay. Mm. So that's why we have to fabricate the sensors which we can integrate through that IoT system, and the people they are used for the testing. Okay. So utilized to provide information on how large variety of the effect and can affect the different type of the cells. Okay. So how can the people, the doctor, if you check the ECG report of the any human being, we can check that this is the signal, some spike of ECG report will be that. If the proper will be click and some spike will be there, some angle that doctor will be recognized. But we have to make the sensors which can save the ECG of the human body, and he will be convert that pulses in the form of the digital form. We have to in the IoT system of the AI and machine learning, we integrate that sensors and we convert that signal into form of the readable in the form of the human being, and it will be if the doctor will be there will be minor changes will be there, maybe it is due to the noise, but maybe this will be the signals before it will be some warning, and it will be human will be not read and not will be taken the serious of that report, it will be more dangerous for that. So early diagnosis of the disease will be required nowadays, and this will be possible through that sensor only. So this is the cells-based quartz crystal material biosensor. So you can see that this is a quartz crystal. This is the blood cells. And what is the change when the blood will become? You can see that graph of the electrical graph. This will be before that blood cells. This graph will be like that. When blood cell will be exposed on that devices, we can check that it will be changed this waveform. So what will be happen? This impedance. Suppose this impedance is a Z naught. What this impedance is a Z after the exposure EA. We can check the difference of that impedance. So by attachment and spreading of the mammalian cells on the solid electrode of the quad sensor, we can monitoring change in the beating rate of the cardiac myocytes due to the addition of the drugs. We propose a cell-based to demonstrate this method. We use the monitor to mechanism tools. Okay, so addition of the drugs, we can check that when we insert the drugs in the human body drugs, what will the needles will be insert in the cells or nerve of that human body, and it will be clear the pains. But we make the drug delivery system through the MEMS technology, which will be not use the nerve system, it will directly deliver to the blood. Okay, so this is the cell-based biosensor for disease detection, impedance biosensor for measurement of the immunoreaction coupled with the red blood cell RBC applications. So we have the gold electrode materials, and this is the materials. Okay, so magnetic, this is the magnetic bead, capture antibodies, this is the antibodies, immobilize antibodies, and this is that H1N1 virus, this is the virus, that blue, and chicken red blood cell, this is the blood cells. Okay, so gold electrode surface modification by the, we have to check that H5N1 variance binding and detection, RBC amplification. RBC are used to biolabel to detect the captures these cells, because this will be present in the blood only. So we have to take the RBC, okay, and then we have to check. Now the biosensor. Now we have to move that application of the MEMS sensor in automobiles. So what is the MEMS? Micro electrical mechanical system. Means we have the combination of the electrical and mechanical, both. Electrical, we have to integrate the sensors. Mechanical, the movement of the parts or something else. So if you seen that we have to focus on the safety of the automobiles. Government of India also work on the safety of the automobiles to make the less accident, to save the life of the people. If you compare that car Alto and Mercedes and that Jaguar car, or Royals cars, you can check that, see that only the, you can see how much the price will be, difference will be there, because price will be depend upon that specification and features of the cars. Alto is the basic cars which have the only two airbag in the front, but the Mercedes will be contain around 16 airbags. Okay. Recently, that one cricketer, that I don't forget the name, who have faced that car accident, and his car fire will be in the petrol will be there, and his airbag will be open, and then he will be safe now. Okay, because the car will be Mercedes. Okay, and the uh, response of that sensor will be in the nanosecond or in the picoseconds. Okay, that's why the airbag will be open immediately. But what happened in the many cars, that in a Hyundai, and I have not to make any complaint or not to compare that car, but sometimes the car airbag will be not open even after the accident. The reason is that sensor will be not work at that times. The quality of the sensor is very poor, and it will be response time is very poor. Okay, and the people will be die. So we have a lot of the applications of the car in the automobiles. So MEMS sensor and extruder used to control various elements of the automobiles, power, train and chassis control. Example, manifold, air temperatures. Okay. So now the car will be come with the power steering and chassis control. So we use the air temperature control sensor. Comfort and convenience. Example, air temperature, communication wireless. You can see that in the car you have the GPS system, you have the Bluetooth system, you have a FM system. Everything will be in the car. Now car will come with the AI and machine learning. Okay, if you see that MG Hector car will be properly based on the AI technology. It will be work on the command of the voice of that human being. If I told that car to lock the system, to lock the door, it will be automatically locked. Okay. If I make the instruction to the car, please open the door of the car, it will be open. It will be down that window glass will be automatically on the command of the voice of the human being, because it will be contain the sensors. When I command to the my devices, it will be converted into a signal, and signal will go to the sensor, and sensor will be automatically work. So how that work, it have to integrate that rotate that window slide. We have the RPM motor will be there. The motor will be moved that window glass of that car. So what is the autonomous vehicles? You can see that two figures. If you are from Delhi and Mumbai or whatever that is a metro city, now the Delhi have the driverless metro, automatic metro will be there. Okay, means it will be driven by the woman. No operator, no train operator will be there. Okay, so self-driving car with the sensors able to observe and understand the surrounding. So we have to fix the sensors. He will sense everything, that where we have to move, what is the in the backward will be any car, so there will be any car on the parallelly in the front of the car, what is the distance the car should be maintained to make not the accident. So we have to put all the sensors to make the car autonomous. So automated function today. So manual driving, automatic transmission, cruise control, ABC and stability system, electrical power steering. So assisted driving, human driver in the control, adaptive cruise control, collision warning system. These all are the warning system are will there in the car, and this will be due to that sensor only. We have the all type of the sensor will be fitted in the car. So possible sensor technology for the autonomous vehicles we have, like that we have the GPS sensors which provide the locations, lidar sensor camera which check that anything will become on the front of the cars, like that some animals, some trucks, some vehicles will be in the front of us, so he will be detect that position of the vehicle, how much it will be far from the car. Okay, and it will be come to nearby, it will be either to stop, or it will be make some turn to avoid to accident, to make that animal will be not come in the front of that car. We have the radar system, we have the inertial sensors, we have the center computer, we have the odometry which check that odometry will be check that uh, volume that of air, that pressure of that our tires. Okay, and ultrasonic sensors, that sound sensor, some strike will be that accident will be happen, and ultrasonic sensors sound will be move that. So what will be that in the nowadays people are driving the car, and some pinchers will be in the tires, so leakage of that air will be that there, and when whole the air will be passed, then people will be recognize that our tire will be pinchers. And what will happen if the speed will be more, then car accident will be happen. But if we have to put the sensors, it immediately give the sense that our car the tires pressure will be down. It means we have to stop the car and check that what will happen with the tires, so it will be avoid that accident. So We have the sensors enabling autonomous vehicle to see this camera view. You can, this is the animation diagram, you can see that here. Okay, these are the animals, this is a tree, this is the car. So this camera view will be captures that image of the animal. So camera record video interpreted by the computer vision algorithm can distinguish and classify the objects such as sign, landmarking, traffic light. May also be able to classify more complex objects such as animal and pedestrian. Can only see what camera can see. Challenges in the low light or bright light or sunlight. Any questions till now? Second is the sensor enabling autonomous vehicles through radar. We have seen. Car transmit radio wave and interrupt the back reflection from the object. So we have the radar system. If any object come will be between that our car, it will be transmit the radio signals and he will be detect that some item of object will come out in front of that car. This is the lidar, can transmit light pulses and enter the back reflection from the. So we have to focus the light and some reflection of the light will become backward. Okay, and we can check that there, if there will be reflection, there will be some object in between the car, so light will be reflected back, means some object will be come in the front of car, so you have to slow down the speed or you have to be careful. Sensor technology, one size does not fit all. Okay, means autonomous vehicle will utilize variety of the sensor technology. Different sensor have a different strength and weakness. Sensor fusions. So these type of the sensors we have the car, that you can check that from this animation diagram. Okay, so we have the surround view sensor, blind spot detections, radar collision warning, park assistance. You want to parking, then there is a camera in the behind the parking, and from that image you can check that there is in the when you have to do parking or you have to take the back of the car, if some object will be on behind, some small object you cannot see in when you are sitting in the car. So through the camera that you can verify that there will be no that anything behind the car and you can park easily that car. Adaptive close control, land drops warning, cross traffic alert, everything will be there. So this is the automotive main summary, that you can have fuel pressure sensors. That fuel pressure sensors will record that how much the fuel will be remaining in the tank, and it will be display on your car that this much fuel will be there. So you can either suppose that there will be no sensor of the fuel in your car, and you are traveling around the 500 kilometer, and you suppose that you full the tank, and after that 400 kilometer and between 500 kilometer there is no petrol pump. So in between that your petrol will be, there will be no petrol, and how will be for 100 kilometer, how will you go? So there will be put you sensor, it can indicate that this fuel will be remaining, so you can in between that petrol pump you can fill your tank with the fuel, and your journey will be more happy, safe. There is a one inertial navigation sensor, acceleration, yaw ratio, silicon nozzle for fuel injections. Okay, air conditioning compression sensors, manifold air pressure sensor, mass airflow sensors, pressure and inertial sensor, airbag side effect sensors, fuel sensor, level sensor, crash sensor. Every these all the sensors will be in the automatic car nowadays. So now we have to move that Arduino. Okay, so Arduino. Are you familiar? Everyone will be familiar with the Arduino from their BTech and MTech class. If you work in the some project of the electronics, okay. So this is the we have the chips we can it is very easy to make that coding and integrated our sensor with the Arduino sensor and display with the some unit LCD LED where we want to 7 segment LED you want to interface. You can through coding do the coding in the LED, put the sensor and you can display that. So this is the Arduino software 1.0 diagram where you have to do coding. So these are the printf and void. If you are from the background of that computer science and electronics, or you have the more knowledge of the coding that sees the one and everything, and you directly write the code that how much that. Suppose I want to integrate the sensors like that smoke sensors. Okay, so what will be happen in the smoke sensors? You can check. You have the smoke. There is a one sensor smoke. When someone will be smoking here, it will be detect the sensors. And we have the suppose the 3 or 4 pin of the sensor, and we have to integrate these 3 pin here only. Okay, so we have to assign that pin, that what are the pin diagram, that which pin it is, that suppose that pin 1 is assigned to LED 0 5 volt -1 volt. These are coding you have to done here, and you have to integrate this Arduino. Okay, so this is the keypad module. So you want to integrate your keypad module through the Arduino. So these are the output pin which are connected to that Arduino pin here. uh, if someone is having any problem, they have not seen the Arduino, or they have not aware that how to make the coding in the Arduino, or if you want to more about known about the Arduino, you can check on the Google that pin diagram of the Arduino also, that what type of the Arduino available in the market, and it is very low cost that you can buy yourself. The 250 rupees 300 rupees cost is almost that Arduino. And if you want that I will explain more about that Arduino, then please let me know on the ask a question form on the spam podcast. And maybe next class if someone have the issue I will take that comment also that. So most used sensor for Arduino like the temperature sensor, humidity sensors, smoke sensors, fire sensors, we can use through the Arduino. So second is the IR sensors. This is the we can integrate the IR sensor through the Raspberry Pi or any other system on the board of LED. So this is the code how to IR sensors will be connected through the Arduino. So IR sensor with the digital input in the pin number 2. Okay. So we have the void that is already that fixed that command, that instruction set. We initialize the digital pin as output. Pin 13 has the LED on the Arduino board. So we have connected on the pin number of 13 of that LED. Like that, this is the LED. We connected, one is the ground and one is the VSS. And VSS will go to the pin 13. Pin mode 30 is the output, means this from this we have to take to the LCD. Pin 2 is connected to the output of the IR sensors. So pin mode IR sensor is the in mode, void in loop. If digital read IR sensor is the high, means if the IR sensors value will be high, means 5 volt or 10 volt, then what will be happen? Digital write 30 a high on the LED. Means on the pin number 13, you have to write that this will be high. Else on the pin number 13, if the value is the low, you have to write low. And we have to give the 1000 millisecond of delay, means the input delay, output delay, because it will be maybe the if we take the less delay, then there will be interference of the signal delay. Second is that stepper motors. I think that everyone have to aware that stepper motor. There is a robotics. You can see that example that when you enter in the some mall and some metro system, in the mall that automatic door will be opened, that glass door. How to that we have to put one small stepper motor, and we have to put the one IR sensors which scan that home, and that some object will become on that front of that door, and it will be give to the signal to that Arduino, and that stepper motor will be also connected to the that signal. And if the some object will become, means the value of that sensor will be high. If the signal will be high on that pin of number of 13, then it will be directed to the stepper motor to move that stepper motor. Means you have to move the open. So motor will be open, then gate will be open in that case. Same case will happen in the micro. So when you have to put your card on that display has some sensor, some image sensor or some camera sensor. So it will be recognized that some person will be inserting that card and he want to enter that card. And what will be that card will be read with that value, that it has some amount, minimum amount will be there. He will be able to pay that money of the air travel or not. Okay. And when he check that property, that card will be okay, that one will be money, then what will be happen, that gate will be open, everything that for you, and he will be there. After that move to that gate will be automatic close. That close will be happen through the motor, that movement of the gate will be happen through the stepper motor only. So it is stepper motor is also called a digital motor. It takes digital input to move by the step. So digital input means 1 and 0. Its waveform will become, if 1 value means high, if 0 means will be 0. So when will be 1 will be there on the input of the step motor, that gate will be open. If it is 0, gate will be the close. So it stepper motor is specified by the step angle of the say 200 step per revolution. Means on the one revolution, it will take the 200 step. Means 1.8 degree per step. Any doubt? Anything you want to discuss? So to move a step, we need to provide a digital input sequence on the winding. Means the stepper motor some have the winding, copper winding on between that. If the signal will be there, the electromagnetic field will be generated in the copper winding, and this movement will be happen. It is the basic principle of the motor. So if you not know about the motor, you can read about the working principle of the motor that. So sequence of the bipolar or uniform, you can motor to the bipolar 10001 and repeat of the sequence of the field. This is the step. So you have to write a program to run a stepper motor in the clockwise direction. Means this direction. Your motor move in the clockwise direction. So you have to integrate that stepper motor through the Arduino, and you have to write the program so that stepper motor connected in the Arduino board, and it will be move in the clockwise direction. So stepper motor speed control is a one evolution. This program will be you have to include. Okay. So this is the program. So what will happen? Constant in stepper evolution will be 200. We already do know. So we initialize the stepper library on pin 8 through 11. So stepper motor step evolution will be 8, 9, 10. That 4 step. And then we have to set the speed at the 60 rpm per second. Means rotation per minute 60. Means in 1 minute it will be rotated 60 step, and we have put the how much as 200 step. Means it will be taken around 3 minutes and some second. Okay, and this will be initialized on the serial port, and that everything we have to initialize. You can see that this diagram, how the people that will be this will be connected you through that motor and everything, that signal. This is the Arduino mode, breadboard, and that signal here too. This is the pressure displacement sensor. We check the displacement. It will be display of the LED through that. The motor will be this stepper motor. So glow will be happen with the movement of the LED, that it will be rotate 60. That which LED will be remove and everything that. So if you go through that video, 1 minute, I will show some video where you can explain something that. Oh, see that how he moved that. This is movement of, they have used the stepper motor to movement. He manually moved, he changed that potential of that sensors and stepper motor, and he moved that step. Okay. So this movement will be happens if you go through that portal, some video
Hey,
of the
welcome
class.
back to another episode.
I will show you. So if you go the tutorial for basic of microsensors, they have demonstration of the DC pressure pump using Arduino in this video class. You can check that.
Number 8, syringe pump, where you continue the macrofluidic chip should be connected. Pump has a media, pull the peristaltic pump, your drug particular aspect.
Talking about an actuator that is called as peristaltic pump. So there are water pumps. Pumps are devices or actuators that are used to move a fluid from one point to another. Okay, so we use different type of pumps, maybe centrifugal pumps, peristaltic pumps, etc. Okay, we will be showing demo of one of it. Okay, so there is the pumps can be classified into different categories. Okay, positive displacement pump as well as centrifugal pumps. Okay, so peristaltic pump is type of a positive displacement pump. So you must have discussed about positive and positive displacement pump as well as centrifugal pumps in the previous lectures by the professor. So I will be showing the demonstration of.
So he will be. So he will be teach about the type of the pump that he will be explaining in this diagram. So he used some fluidic pump to move that through the stepper motors. So he will connected through that Arduino. There is a breadboard, and he have connected all the component. This motor will be that stepper motor. You have to show the example. How will you integrate it? You show through this video. So you have to more about that, how to connect it that systems.
Peristaltic pump, which is a positive displacement pump now. In the screen, you can see two pumps. This is a 12 volt peristaltic pump over here, and this is a costly peristaltic pump for microfluidic applications. You must have seen the one of this kind of peristaltic pump as part of the lab videos. Okay, these peristaltic pumps are positive displacement pumps, and they are used for very precise applications, especially in microfluidics, drug delivery, and other things where the flow has to be controlled very accurately. Okay, so we have a bigger peristaltic pump which are like costly as well, but at the same time they can regulate the flow in the rates of milliliter per hour and also, which is kind of very minute volume of fluid that is being pushed. And this is a higher volume displaced as well as 12 volt motor. Okay, now I will show you how a peristaltic pump works. You can see here in a GIF image. Okay, you can see that the fluid will come through this port. Okay, so it will come over here. So what we have is a rotating roller kind of thing. Okay, and in that rotating roller itself we have some small different wide rollers also you can see. So what happens is, this is the casing of the motor or the peristaltic pump, and there is a flexible tube over here. So the water or any fluid that is to be pumped will be coming over here, and what happens is, when the roller rotates, this roller will come and push the fluid within the tube between the wall here and the roller, and push it to the other end. Okay, that's how the pumping of a peristaltic pump works. So this is a positive displacement pump. That means that the fluid will move only in one direction. Okay, so this is a positive displacement pump and this is called the peristaltic pump. Okay, this process, this flow process is called as peristaltis. It's present in even human body. I have a peristaltic pump like what you saw in the image previously. So this is a small 12 volt peristaltic pump. I will open up and show you how it looks like inside. If we give the input fluid in, and then input will come through this tube, and you can see that is just nothing but a DC motor only here. Okay, so the DC motor is what is rotating that roller that I have shown here. That there are rollers here. So you can see that the tube is over here, and you can see there is a motor. There is like what you saw in the GIF. Ways this is roller unit entirely will start to rotate. Okay, will be but it will still work. So this is the internal. Against, and it has nothing but a DC motor, but with a different.
So I think that I have some network issue here. Uh, we finish the class here. We will. Okay, thank you. We'll meet on next.